Hello children, welcome to our science session. In this session, we shall be revising chapter 14 chemical effects of electric current with some activity from your NCERT science textbook. So children, in this chapter first we have learnt about what are electrical conductors and electrical insulators. Here you can see some examples of electrical conductors are silver, gold, copper, steel, seawater, etc. And electrical insulators, or you can tell poor conductors of electricity, are rubber, glass, oil, diamond, dry wood, etc. So what are conductors? Materials which allow electric current to flow through them are called conductors. And what are insulators? Materials which do not allow electric current to flow through them are called insulators. Conductors and insulators of electricity, if you see, that is what is a conductor is any material or any substance that allows electricity to flow through it, and an insulator is any substance or any material that do not allow the electricity to pass through it. Any substance can be called as conductor of electricity if it allows the movement of electric charges through it. How it happens? The electrons of the conductors, they can freely flow, and hence it take electric current through them. Insulators do not allow the flow of electric charges through them, because their electrons are tightly packed with their particles. That is the reason why conductors, they allow electric current to flow through them, and insulators, why do they do not allow the electric current to pass through them. Now, some materials that can allow only little flow of electricity through them are called poor conductors of electricity, and some materials that can allow the complete flow of electricity through them are called good conductors of electricity. Every material, they may conduct electricity in certain situation. For example, if you see, air is a bad conductor of electricity, but during lightning or during thunderstorm, air carries electric charges through it. Hence, materials are always classified as good conductor or poor conductors of electricity, rather than we can call them as conductors and insulators. So children, materials are broadly classified into good conductors of electricity and poor conductors of electricity on the basis of uh, conduction of electricity, rather than conductors and insulators. Can liquids conduct electricity? Yes, not all liquids can conduct electricity. However, some liquids we considered as good conductors of electricity, while others are poor conductors of electricity. For example, water containing salts and minerals dissolved in it, they always conduct electricity. So they are good conductors of electricity. But distilled water, which does not contain any salt, they cannot conduct electricity. So they are poor conductors of electricity. And the same way, any solution of acids or bases can also conduct electricity. So good conductors of electricity, you can tell water with salt and mineral dissolved in it, acids and bases are all example of good conductors of electricity. But distilled water, as it doesn't contain any salts in it, they are poor conductor of electricity. Now, how do liquids conduct electricity? That is, whenever electric current pass through the liquids, it should break into uh, ions. That is positive ions and negative ions. Positive particles or negative particles, what we call that as ions. These ions can pass the electric current through them. The more is the number of ions in a liquid, the better is the conductivity. That is why distilled water is a poor conductor of electricity, but salt water is a good conductor of electricity. But however, many compounds, they do not form any ions. Therefore, they are poor conductors of electricity, such as if you see sugar mixed in water, that is sugar solution, oil and alcohol, they are all poor conductors of electricity because they do not form any ions. That is why they are poor conductors of electricity. Now, how do we find out if the liquid can conduct electricity or not? By using by a tester. Isn't it? Tester should consist of two, that is conducting wires, two terminals. The free end of the terminal is attached with the battery, and the other end of the terminal, it is conducting wire should be attached with the two free ends of the conducting wire is attached with the bulb. So if the lamp glows, the bulb glows, then it means the liquid conduct electricity. Isn't it? The two ends, conducting terminals of the conducting wire, free ends of the conducting wire should be immersed in a liquid, and if the circuit gets completed, if the liquid is a good conductor, then the bulb glows. If the bulb doesn't glow, then we can understand the liquid is a poor conductor of electricity. But instead of that ordinary bulb, LED bulbs are more suitable for testing electrical conductivity of the liquid. Why? Because the electric current often they causes heating effect, due to which the filament of the bulb gets heated and then it glows. But however, some liquids, even though they conduct electricity, but the electric charge, the electricity, they are very weak. They are weak conductors of electricity. Hence, the current passes through them, but it is not strong enough to heat up the filament. As a result, the filament would not light up in case of such liquids. But the LED bulbs can use to find out the flow of even a small amount of electric current as well. That is why LED bulbs are more suitable for testing electrical conductivity of liquids. Now, how do we find out this electrical conductivity? We have learned about this electrometer, that is which consists of two electrodes, positive electrode and negative electrodes, and then electrolytic solution, isn't it? Now, this process, what we call that as electrolysis. So what is electrolysis? The effect in which the component of a compound can get split due to the passing an electric current through it is called as electrolysis. And what are electrodes? Electrodes are the terminals through which current passed into a liquid. What is an electrolyte? Electrolyte is a solution that breaks into its ions. On passing electricity through it is called an electrolyte. So this electrolyte, we have learned, they are used in the process of electroplating. Now, what are anode and what are cathode? The positively charged electrode is called as anode, and what are cathode? The negatively charged electrode is called as cathode. Then we have learned what are anions and cations. Anion is a negatively charged ion and cation is a positively charged ion. Then we have learned about different effects of electric current. Whenever electric current passes, it produces heating effect or mechanical effect, magnetic effect, and chemical effect. So what is heating effect? Whenever electric current passes, it causes heating of the electrical equipment. For example, the filament of the bulb gets heated up whenever the electric current passes through it, therefore it glows. It is an example of heating effect of electric current. Mechanical effect, where the electric current that leads to the generation of mechanical energy in appliances. For example, rotation of fan and working of motor, they all due to mechanical effect of electric current. Then magnetic effect, whenever electric current, it can give rise to the magnetic field of a substance, is called magnetic effect. Then chemical effect, electric current can lead to the production of chemical energy or some chemical reactions is called as chemical effect, isn't it? And now let's discuss some activity. How do we find out whether the tester, whether it how it used to find out the given substance or given material is a good conductor or poor conductor of electricity. Now what we have to do is we have to join the free end of the tester together. And that is tester, it includes, we have as given in the figure, two conducting wires. One free end of the conducting wire is connected with a cell or battery, and from again the other conducting wire is attached to the two ends of the free end of the conducting wire will be attached to the bulb, isn't it? Now if the circuit gets completed and the bulb should glow. However, if the bulb does not glow, it means the tester is not working. Can you think that is only the possible reason? We cannot immediately decide the tester is not working. There is other possible reasons also. We have to check whether all the connections are in proper tight, or we have to check whether the bulb is fused or not, or we have to check the cells, whichever we used, whether it is drained out or not. And then we have to check all the connections. We have to make connections tight. If they are, then if it is still, then replace the bulb. If the bulb is fused, we have to replace the bulb with another bulb. Even now the tester is working. If not working, then we have to replace the cells with fresh cells. So what did you understand from this activity? In this activity, if the bulb does not glow, it means that either the connection of the circuit are loose, or the bulb is fused, or the cells are used up. If the tester is working, it can be used to test the material, that is whether it is a good conductor or bad conductor or poor conductor of electricity. Now next activity, that is about testing the conduction of electricity in lemon juice or vinegar. Now we have to take a small plastic cap of used bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in 1 cup, and we have to keep the tester over this cap. That is the end of the tester, you should dip in the lemon juice or vinegar as given in the figure. Now we have to take care that the ends are not more than 1 centimeter apart, or at the same time they should not touch each other. That end of the test, the end of the tester here, the ends of the tester should not touch with each other. Now if you keep the setup like this, now does the bulb of the tester glow? Does the lemon juice or vinegar, whatever we have taken, they conduct electricity? Now how would you classify lemon juice or vinegar a good conductor or poor conductor of electricity? So if you keep the setup like this, in this activity, what happens? The bulb glows, which shows that lemon juice or vinegar, in both the cases, if you take lemon juice or vinegar, if you take, bulb will glow. So this shows that lemon juice and vinegar conducts electricity. Hence, they are good conductors of electricity. Now, next activity, let's use about this by using another tester. That is here we can, you have to take the matchbox tray, that is discarded matchbox without matchstick. We have to take the tray of the matchbox, empty matchbox tray, and wrap an electric wire few times around the matchbox tray. Now we have to place a small magnetic compass needle inside the tray. Now connect one free end of the wire to the terminal of a battery and leave the other end free. and take another piece of wire and connect it to the other end of the terminal of the battery. Now join the two wires, two free ends of the wires for momentarily for some time. We can see that compass needle shows deflection. Hence, we can find out our tester with two ends of wire is ready for testing. Now, we have to use this tester for repeating the same activity, whatever we have performed in the previous one. That is, we have to keep the free ends of the tester in a lemon juice or in a vinegar. Now, do we find any deflection? That is, magnetic needle of a compass, it moves, that we what we call that as deflection. So do you find the deflection in a compass needle? Yes. Now the same. If now you remove that lemon juice, remove the free end of the tester from the lemon juice, and what we have to do is clean it with water and wipe them dry, and repeat the activity with other liquids such as tap water, vegetable oil, milk, honey, etc. While repeating, while we do that activity with other liquids, every time we have to wash and wipe the end of the tester after testing each liquid. In each cases, we have to observe whether the magnetic needle shows deflection or not, and we have to record our observation. And what we can find is the materials, the solution, given solution, or good or poor conductor of electricity, whether the given liquid is good conducting liquid or poor conducting liquid. So in case of lemon juice, vinegar, tap water also, it contains some salts and minerals in it, isn't it? Tap water, then milk, soda, curd and water. In these cases, if you see, we can observe the deflection of magnetic needle. So this shows that these liquids are good conductor of electricity. On the other hand, vegetable oil, honey, distilled water, kerosene oil. In these cases, magnetic needle does not show any deflection. So these are all poor conductors of electricity. So by seeing the deflection of magnetic needle, we can find out whether the given solution is a good conductor or poor conductor of electricity. Now, now let's discuss about other activity. We have to take two teaspoons of distilled water in a clean or plastic cap of any discarded bottle. And distilled water, where do we get this distilled water? From our school science lab, or you may also get it from some medical store. Now the same tester what we have used in that previous activity, or we can use that tester with a bulb also you can use to find out whether the distilled water conduct electricity or not. And if does distilled water conduct electricity, now we have to observe that. Now again what we have to do is in distilled water, now dissolve few pinch of common salt in it. Now again we have to test whether this time after distilled water mixed with salt, whether it conduct electricity or not. And now this time what do you conclude from this activity? So, if the tester is put in distilled water, the bulb of the tester does not glow. So this shows that distilled water does not conduct electricity. But when salt is dissolved in distilled water, and if you test it again, this time we can see the bulb glows. This shows that water containing salts conduct electricity. Thus, water which is free of salts, that is distilled water, isn't it? Free of salts are poor conductors of electricity, while water with salts is a good conductor of electricity. Okay, children. So in this session, we have revised about some activity which shows that some liquids are good conductors of electricity and some are poor conductors of electricity. Most of the liquids that conduct electricity are solutions of acids, bases, and salts. So the passage of an electric current through a conducting liquid causes chemical reaction. The resulting effects are called as chemical effects of electric current. That's all for this session. Thank you.